Hey, what's up, Chem peeps? What in the heck are we going to do in this video? We are going to describe a reaction in terms of a molecular, complete ionic, or net ionic equation. As always, breaking it down. Once again, not a whole lot to do. We're just going to write these equations in molecular format, complete ionic format, or net ionic format. Alright, so first thing we're going to do is talk about a net ionic equation. In a net ionic equation, we're only focused on those compounds and ions that undergo a chemical change in a reaction in an aqueous solution. There are some ions that do not take part in the chemical reaction and are found in solution both before and after the reaction, and we call those spectator ions. They're just watching the chemistry happen. All right, as an example, let's come back to this reaction between sodium chloride and silver nitrate that we were working with in the previous video. When I mix these two solutions together, recall that one of the things that is going to form is going to be our solid precipitate silver chloride. And notice at the molecular level, the silver ions and the chloride ions precipitate out. They are doing some chemistry. But notice that the sodium ions and the nitrate ions are still floating around in solution just like they were before. They're not doing any chemistry. They're watching, spectating, they're watching the chemistry happen. So we call them spectators. Now, how can you identify spectator ions when you don't have a fancy simulation to help you better visualize that? Well, you can identify spectator ions if they are aqueous ions before the reaction on the reactant side and are still aqueous ions on the product side. So in this example precipitation reaction between lead-2 nitrate and potassium chloride, the potassium and the nitrate are both spectators. They are watching lead-2 and chloride ion actually do some chemistry, form this solid precipitate lead-2 chloride. However, keep in mind it doesn't have to be just a precipitation reaction. In this example, acid-base neutralization reaction, it's the potassium and the chloride ions that are acting as spectators. They are watching the hydrogen ion and the hydroxide ion come together to form water. So bottom line, if you've got an aqueous ion in solution before the reaction happens, and that same ion is an aqueous ion in solution after the reaction, you know it's just watching the chemistry happen. All right, let's practice writing a net ionic equation. First, what we're going to do is write the molecular equation. This is just the type of equation that we're used to writing. All right, as you take a look at the example in your notes, we've got the reaction between aqueous ammonium sulfide and cadmium-2 nitrate to form ammonium nitrate and solid cadmium-2 sulfide. That's our molecular equation, like you know and love them. Your second step is to convert the molecular equation into what is called a total or complete ionic equation. What you're going to do is just going to separate out all of the soluble ionic compounds and show them as dissociated ions in solution. So here's the second step. I've rewritten this molecular equation in complete or total ionic form. Notice all I've done is taken all of my aqueous compounds and written them out as individual ions. Because in solution, those ions are going to be separate from one another if they're aqueous. So I'm going to have 2 ammonium ions, 1 sulfide ion, a cadmium ion, and 2 nitrate ions as my reactants. On the product side, 2 ammonium ions and 2 nitrate ions, aqueous in solution. My cadmium sulfide, however, I'm going to keep stuck together because it's a solid. Your third step is to cancel out the spectator ions. Again, in a net ionic equation, our focus is on just the actual chemistry. And so those spectators that are just watching it happen, we're going to cancel them out so we can focus on the chemistry. So as you take a look at this amazing setup that I have, notice that ammonium ion is aqueous before and aqueous after. That means that the ammonium ion is a spectator. So I'm going to put it up here with the spectators. Notice that the sulfide ion is originally an aqueous ion, but then forms part of the solid precipitate. So I'm going to drag that down here. It's a player. It's actually taking part in the chemistry to form this solid precipitate, cadmium-2 sulfide. As I take a look at the cadmium ion, it is also taking part in the chemistry. It's aqueous before and part of the solid precipitate after. The nitrate ion, on the other hand, just watching the chemistry happen. So I'm going to move that up here with the spectators. And our final step, just rewrite the net ionic equation without the spectator ions. That's what a net ionic equation is. The equation without the spectators. Boom. Here's your step 4. Here's my net ionic equation. All right, and that does it for this video. Have a fantastic day.